Well, greetings from Berkeley, California. This is Alan Gould here. And wish I were there, but it's hard to travel these days sometimes in schedules. Anyway, I wanted to give you a little report on things that are happening with HOU USA. The next slide. Just two things. You know, we have been going through a process of setting goals and objectives to try to reinvigorate the USA HOU. And one of the components that is in that is an astronomy modeling course that we're developing. So let's get into the goals and objectives. Next slide. Whoops, this is from another talk that I'm doing. Okay, how did that slide get in there?
Let me see.
Let's go to the next slide. Okay, so we have different levels of goals, but the top level is this mission that everybody probably has and all HOUs have, is to inspire the next generation of STEM explorers and become actively engaged in astronomy, science, and engineering practices. That's the overall mission. Let's go to the next slide. There are 6 goals that we've come up with, and this is a process of some online meetings that we've had over the past year, and there's been a core group of people who have been participating in it. One of the organizers actually is Rich Lohman, who you see here. I'm going to show little pictures of each person who's been or some of the people who have been participating in these goal setting meetings. So this one, the first goal is to create curriculum materials and professional development opportunities. Those are 2 big areas, but they kind of go together. When you develop a curriculum, then you have to have professional development that goes with it. Next slide. We also, as part of, this is actually in a way part of curriculum development, but an essential part is to provide image processing software. And the one that's been used mostly for the past few years is, of course, SALSA-J. But there is desire for other types, like server-based software that will work with mobile devices and things like that. So this is a goal as well. Tim Spuck was part of he was actually one of the key people who was guiding this goal setting process. Okay, the next slide. Kate Meredith works at Yerkes Observatory. This goal is to provide access to a network of telescopes, databases, and collaborators. And of course, Yerkes Observatory is a key part of such a network. And there exist networks. In fact, I might mention that one of the things that has already happened is making a little database of existing telescope networks. It's been compiled by a student who was working for Kate, and it's being added to periodically, so or sort of ongoing. And I think we're going to make that available online on the HOU website, which, by the way, I mentioned that HOU website is part of the Global Hands-on Universe website. So if you go to Global Hands-on Universe and just put /USA, USA website is part of Global Hands-on Universe website. And I would encourage all countries who are part of HOU to do that. Would make for a unified thing. Okay, next slide. All right, Patrick couldn't be with us today, but he is an essential player in Goal 4, which is to engage learners in real-world astronomy-related research projects. He runs the IASC, the International Astronomical Search Campaign, which has been discovering bazillions of asteroids and getting them named after schools and students who discovered them. Actually, the discoveries are not that many, but they've been observing a lot of asteroids, confirming orbits and things like that. Next slide. You might recognize this person. So to diversify the future STEM workforce through engagement of underrepresented groups. Now that's kind of a tall order, and we don't have any active programs in that other than some participants who are serving underrepresented groups. And I guess when you get right down to it, that's one way to do it, is to just have them part of your organization. The next slide is the last goal, and that you might recognize that person too. Develop sustainable learning communities of educators, scientists, students, and others. This is where distance meetings actually really comes in handy. And I think that Julie's talk was very good along this lines, is to find the best platforms for communicating is very important, and to develop the best strategies for communicating across distances is very important. Okay, the next slide. I just want to briefly say, I'm not going to go through all of these, but under each of the goals, there is a set of objectives. And so I'm just going to give one example of an objective that was for goal 1. And this objective, but by the way, that's Vivian Heddy, who is also at Yerkes Observatory in Wisconsin. This objective to design activities, tutorials, and curriculum materials. And the example may include modeling instruction, project-based learning. Modeling instruction is one of the ones that we're actively involved in now. And under each of these objectives, there is a set of tasks, if you will. Go to the next slide. And tasks or action items. And specifically in developing our modeling course, which I'm into the second part of this talk now, we had a workshop in June at Lawrence Berkeley Laboratory. Carl was there, I was there, Rich Lohman, Jennifer Prasso who's pictured here, and a team of modeling instructors. Okay, so let me explain a little bit more about that and what we're working on. Go to the next slide. In this course, we are going to, we brainstormed some key, or what we call guiding questions. And so there are going to be 4 guiding questions that will govern the whole course. How do we measure space? How do objects interact in space? How do we know about space and things in it? And how do things form and evolve in space? Those are what we settled on. In the next slide, by the way, that's Colleen. That was a picture of Colleen, who is a leader in the modeling instruction movement. One of the reasons why this is such an important thing for us to get involved with is that the American Modeling Teachers Association is a very active organization. They run workshops, and it's a very good partner for us. Modeling instruction, just to give you a little background, is it's something that was developed in the 1990s, actually, and it's a very vibrant, up to this day. Modeling cycle, it's basically to get students to create their own models, okay, and to learn by the modeling cycle is to build their own models, to then test the model out and apply the model in a variety of situations. It's similar to some other curriculum ideas, in that student-to-student communication is very important, not just teacher-led. In fact, teacher-led is not important in this instruction. Okay, the next slide. Let me give you a. Oh, this is a kind of, by the way, the next generation science standards in the United States. Oops.
I'm sorry.
We're accelerating the talk here. I'm running out of time.
Hint?
Yeah. Okay. So yeah, we'll go to the next slide. Let's just quickly go through the units, and that will be it. Unit 1, how do we measure space? We focus on SALSA J and use units, appropriate units, and all the different things that you can do with SALSA J to determine distances and sizes. Okay, and we introduce the idea of the distance ladder for nearby objects and far objects, both on Earth and in space. Next slide. How do objects interact in space? This has to do with the motions of objects and how and what is the cause of the motions of objects, which of course is gravity. And so we get into the effects of gravity, Jupiter's moons, the solar system, Isaac Newton's law of gravitation, and Kepler's laws. The next slide. How do we know about things in space? This gets into light, okay? And so we use start out with a what we call a particle ray model, which as opposed to the wave model. And that's useful. The particle ray model is useful for explaining a number of things, including phases of the moon and eclipses. And then later in this unit, we add the wave model and a critical idea of the Doppler shift, which comes into many topics like binary stars, discovering exoplanets, and then brightness. The brightness actually is by itself is something that's used for studying variable stars and also discovering exoplanets. Okay, and the last slide is how do things form and evolve in space. This is one that Carl was working on a lot, which brings into the course some of the most recent topics in astronomy. Okay, so in this one we start out completing the distance ladder, using Cepheid variables and going out to distances of galaxies, and then the Big Bang actually. That leads to the idea of the Big Bang and the expansion rate of the universe. We return to use Doppler measurements for galaxy rotation, the anomalous behavior that is observed in galaxy rotations, which led to the idea that there exists dark matter. And as the last point, I might mention that the next generation science standards has guided these things, and so one of the elements that we have to include, or that we want to include, is the life cycles of stars and how elements are created in stars. So that's a really quick overview of this course, which is under development, and one teacher is has started field testing it right now. So it's in the very early stages of development, really, development and field testing. But thank you for allowing me to come and speak at this conference. I'm very honored and privileged to be here. Thank you.